So is this a mean or a proportion?
Mean.
Mean, is it a hypothesis test or confidence interval?
Hypothesis.
How do you know it's a hypothesis test?
Question at the end.
There's a question at the end. There is a conclusion as well. Kind of follow that? How many samples are there?
Two.
Two samples. Are they two sample mean? Are they independent or dependent?
Independent.
How do you know they're independent?
Because
There's no fancy table for them.
What was that?
There's no paired.
Yeah, there's no pairs of data. Okay, good. We're not going to do it. I just wanted to make sure you folks focus on that part. And then lawn weeds.
Proportion.
Proportion, yeah.
Proportion.
Yeah. Confidence.
Yes.
Proportion. Is it? Why do you say it's a confidence interval?
Because it says
It
it.
says it.
It literally says confidence interval.
Yeah.
Good. Sean, comment?
Just for the last one, when it was pounds and ounces, how would we put
Oh, we wouldn't.
Okay, because I was going to say,
Yeah.
it wouldn't be like...
I wouldn't. That's why I didn't ask you if I do that one.
For sure.
I was like wondering
Yeah.
if I do that.
Yeah. No, I would give it to you as a decimal.
I don't know.
Yeah.
Just curious. It would be like 7.11 on the calculator if you would do that.
If you did it in ounces, you take the ounces, divide by 16 to get it as a decimal.
Oh.
Ah, Shaylee's like, I knew it. Nice
I
job.
go to work every day.
Oh, there you have it. Where'd you work?
Chipotle.
Ah, very good. Excellent. See, math in everyday life. Okay, so everyone find this one. Find the true proportion, find the confidence interval. Okay, so here it's going to be a one proportion z interval, right? Because remember any proportion is to show a proportion, so it's going to be one prop z interval. So I'm going to put in my I have my n. Right, here's my n. And then the 45%, is that my p hat or my x bar or my x?
Yeah.
My p hat. How do I know?
Percentage.
Percentage. So I need to find my x. So 1898 times 0.45. Round to the nearest whole number. What did you folks get to with the decimal in there?
855.
8.
Or
854 point what?
1.
So this is not a minimum. The only time you do the minimum is, the only time that you're trying to find a minimum is when we're trying to find the minimum sample size. N. So that's when we always round up. This one we just round to the nearest whole number. 854.
Wait, can you clarify that again?
Yeah, we're just trying to find what x is, not the minimum x. Does that make sense? It's not a minimum we're looking for. It's just we're just trying to find what x is.
Is it gonna say like by minimum on the exam? Or
If it says how big of a sample is necessary, is needed, that's when we have a minimum. We have to have at least that big of a sample size. So that's when it's a minimum. And if you look on your yellow sheet, it'll also say minimum sample size n. When you have the minimum in there, that's when you have to round up.
But it's still a whole number, right? For that.
Mm-hmm. This is still going to be a whole number.
Okay.
But it's going to be 854.
Okay.
So we use 854. I think that was what you folks were talking about earlier. Is that right?
Yeah.
Yeah. Let's use that one. 1898. And my confidence level is 0.95. Did anybody get it? No?
Oh.
Answer? With 54?
0.42757.
42757. Okay, 76 to 0.4. Okay, seems good. Yeah.
Wait for this one. If it was gonna be 854.7, then you would round up, or would you still round down?
I'm sorry. If it was 854.7, you'd round up.
Okay.
You just round correctly.
Okay.
Yeah. So use the rule of 5. So yeah, if it was 854.7, you'd round up.
Okay.
Yeah.
Thank you.
That's just, and
I just want to make sure that.
it's just,
Right.
that's the only exception.
Right, so you always round correctly except for n when you find the minimum sample size. That's the only time you round up.
Yeah, so she says, we'll just looking for the.
Oh, actually, well, there's, this is percentile.
No, that's not it.
All right, now we're going to take a look at this sheet from the study guide. It's called Exam 3 More Practice Problems. There are a couple in the back if you need any. It's this little one right here. Again, it says more, Exam 3 More Practice Problems. And this is the very first two, 1 and 2. So I want to take a quick look, read those, and I'll give you folks a minute. Okay, so as the p-value gets smaller, what happens to the strength of evidence? Does your evidence get stronger or weaker or the same?
Stronger.
Stronger, right? Smaller p-value means more evidence. Okay, if all else remains unchanged, a smaller sample size has what effect upon the width of a confidence interval? Whenever you're talking about sample size, I want you to think about, again, about evidence and think about error. So smaller sample size should mean more evidence or less evidence?
Less evidence.
Right, less evidence, and it should also mean what should it be? What should it give you more error or less error?
More error.
More error. Does everyone kind of follow that? More error. Left off either. So more error. So less evidence has to do with the hypothesis test, right? This is a test, and then the more error has to do with the confidence interval. So more error means my confidence interval should be what? Wider, narrower, or no effect?
Wider.
Yep, wider. More error, bigger your error. Remember, you have your p-hat, and you subtract your error, and you add your error. Bigger your error, the bigger your confidence interval. The wider your confidence interval. Okay, the next two, or the next one. These are all true, false. I'll give you folks a minute to look at those with your neighbors. All right. The average U.S. salary is $41,000. If I take a sample of 50 people, then there's a 95% chance that the confidence interval will have a lower bound less than 41,000 and an upper bound greater than 41,000. Rack's like, yes, that's true. You're right. In other words, it will contain the mean. Okay. A sample of 42 college students is taken, and they have a confidence interval of 3.1 to 5.2 as their average number of coats owned. Then that means there's a 95% chance that these 42 students own on average between 3.1 and 5.2 coats.
It's false.
False.
I will underline the relevant phrases there. Why is that false?
Why?
Yeah.
You can't have 3.1 codes or something?
Nope.
That's what I thought.
Because it's a control.
Yep.
It's because these students, we already took that sample, and
Yeah. It's these students where I took that sample. Keep going.
it basically makes it redundant because we already have their data. So it's like, why are we recollecting the data again?
We already have their data of these 42 students. So we already know exactly what their mean is. What's their mean? It's smack dab in the middle of these. Right? These students, these 42 students, are what we use to make the interval. So their mean is right in the middle of our interval. So there's not a 95% chance it's in there. It's a 100% chance it's in there. And in fact, their mean is exactly in the center of it. So that's why this one's false. It's about the fact that it's these same students. We don't need to find the average, or we don't need to estimate these 42 students. We know them. They are our sample. They make up our sample. All right, so the next one is, Jason, go and read.
A 95% confidence interval for the mean number of miles that college students live from campus was computed to be 0.9 to 2.3. Then a randomly selected college student will have a 95% chance of living between 0.9 and 2.3 miles from campus.
Okay. So I will underline the relevant part there. What do folks think? True or false?
True.
We're looking at the means, not individuals. So Steph Curry,
Oh,
right? Steph Curry, the average of Steph Curry's games is between blank and blank. Is between 28 and 32 points. So does that mean there's a 95% chance that a randomly picked game of his will be between 28 and 32 points? No, he could totally have a 50 point game. One game, but not an average of 40 games. Does that make sense? Confidence intervals have to do with averages, means of the means, right? We're looking at averages or proportions of the entire population. So looking at the mean, or the mean of the whole population, not one individual. So we talked about this in the quiz. It came up in the quiz before, right? One individual person could be anywhere. They could be a lot. Like a Steph Curry game could be, could be 40 points easily. But if I take an average of 40 of his games, it's going to be a lot narrower. So this one is false. Sean,
Suppose, which one?
top one.
Top one, okay. Suppose a researcher collected data with n equals 200 and came up with a sample mean of 83 and 95% confidence interval of 78 to 88. If the researcher collected another sample from the same population with n equals 200, there would be a 95% chance that the researcher would come up with a confidence interval of 78 to 88 for this new data set.
Good. So take a look at that one, and the next two, I'll give folks a minute to talk over those with your neighbors. Okay, so I collect data. So I sample 200 of Steph Curry's games, and I get an interval from. We'll make it random. Okay, I sample 200 of the Kings games. How many points the whole team scored? And I get a confidence interval of 78 to 88. Everybody good? What's the average for my 200 games then? 83? Yeah, that's in the center. Good. If I take another sample of 200 games, like a different 200 games of theirs, is there a 95% chance that I'll end up with a confidence interval of 78 to 88 with a mean of 83 for those 200 games? Connor's like, no, that's kind of unlikely to get the exact same average, right? This is false. It would be different. All right. If the level of confidence is increased from 90% to 95%, then the margin of error will be increased. So here's my 40 minutes from here to Oakland Airport. Okay, a 90% interval around it, so I'm going to go 40 minutes, 30 to 50 minutes. If I want to be more confident, 95% confident, should my interval become larger or smaller? Larger. Right? The bigger interval you take, the more confident you are that the mean really is in there. If I want to be really sure the mean was in there, I'd go from 0 to like 1,000,000 hours, right? Just, that would be huge. So the bigger interval, the more confident you are. So this is true. A 95% confidence interval for a mean was computed to be 16 to 22. Then my error is, and it won't say plus minus on the exam. It would just say 3. Is my error 3 in that situation?
Yes.
Yeah. Because you know that 19 is in the middle, and that's 3 from there and 3 from there. Okay. Pretty good. Now.
90-60.
The next two, I will give you folks a minute to take a look at these two. All right, my p-value is 0.12. If all else remains changed, a larger sample size will have what effect on your p-value? So again, larger sample size means what? More evidence or less evidence?
Less evidence.
Larger sample size?
Or more evidence.
More evidence.
Yeah, more people you sample, the more evidence you have. Right, the smaller the error, the more evidence. So this is more evidence. So does that mean that your p-value, if you have more evidence, does your p-value become smaller or larger? Smaller. Yep. If a null hypothesis is not rejected at the 0.01 significance level, would you reject at the 0.025 significance level?
Not enough.
Yep. So always compare your p-value to 0.01 to your first part. It says not rejected, so it's bigger than that. That does not tell me whether it's bigger or smaller than 0.025. Let's try something else though. What if it was rejected at 0.01? If it is rejected at 0.01, is it smaller or larger?
Smaller.
Smaller, okay. So then would it be rejected at 0.025?
Yes.
Yes.
Yes. Because if it's smaller than 0.01, it's going to be smaller than 0.025. Okay, one more iteration. What if it's not rejected to the 0.05 level? So here's my p-value. Here's 0.05. If it's not rejected, is it bigger or smaller?
Bigger.
Not
Everybody
enough evidence.
sure about that?
Mm-hmm.
Bigger.
Yeah.
Okay. So then, would it be rejected to the 0.025 significance level?
No.
No. If it's bigger than 5%, it's definitely bigger than 2.5%. Good. Okay. Those are all the iterations we might see there. All right, so then rejecting H naught, what does that mean? Think everything that might apply. So the first four, it's kind of a section, and then we have the next two, and then we kind of have this last one. Okay. So rejecting H naught, do I have strong evidence or not have strong evidence? Strong evidence. Yes, strong evidence. So these two are out. Does everyone kind of follow that? Okay. Strong evidence, is that to support H naught or to support H1?
Support H1.
You never support H naught, ever. So supporting H1. If you reject H naught, is your sample unusual or not unusual?
No.
If you reject H naught, is your sample unusual or not unusual?
Unusual.
Unusual, thank you. And if you reject H naught, your p-value is
Small.
small. Good. What does rejecting H naught, this is continued, there's more. So pick one of these guys, and then pick one of these guys. Rejecting H naught means what? I'll give you folks a minute for these. Okay, rejecting H naught, does that mean I have strong evidence or not strong evidence?
Strong.
Strong evidence, so I'm going to cross these two out. To what, reject H naught or reject H1?
Reject H naught.
Yeah, you never reject H1, you only reject H naught. It is likely that the observed difference in my sample, so rejecting H naught, does that mean that the observed difference between my sample and P naught is due to random chance, or they really are different?
They really are different.
Yeah, they really are different.
Yeah.
Because you're far away. Okay, so we kind of already did problem number 1. So let's just go over that one quickly. So here we find the confidence interval first. So find the confidence interval. You folks did 1 crop Z interval of 323, comma 1,404, comma 0.90, and you got what to what?
0.21158.
21158, okay, to
0.248530.
2485385, okay? What's our best point estimate?
0.2301.
It's p hat. 323 over 1404, which was, what would you say it was?
0.2301.
23? Yep, 230. And then the margin of error. So my margin of error would be my p hat minus my lower limit. Bless you.
101.
And you got 0.0, what did you get for that?
185.
185. Good. Okay. Might be 6 depending on or 4 depending on how you round it. Okay. All right. Go ahead and do number 2. You have 2 minutes to do it.
Is that negative 36%?
No,
Oh.
unbelievable low percentage, comma, or
It's confidence interval.
Oh,
is this a proportion or a mean?
proportion.
Or is it a hypothesis test or confidence interval?
Explaining these samples.
Okay, go ahead. Do it. 2 minutes. Okay, so if folks try to do a confidence interval, you'll find you have no n because this is a find n problem. They didn't give you an n.
Got it.
So you need to use n is equal to your p hat, q hat, critical value over e squared. What's our error?
0.02.
Yep, within 2%. My e is 0.02. So it's 36% is my p hat, which means my q hat is
64.
64%. Great. And then my critical value for a 99% confidence interval, 2.58 or 575, either one's fine, over 0.02 squared. Did anybody finish this one yet?
I got it.
Did you use 258 or did you use 575?
I did 2.576 on the.
Okay, that's fine. Let me change that then. Yep.
So
And what
around
did
it.
you get?
So I rounded to 3823.
3823.
Yeah.
Seem reasonable? Depends on what you put in. If anybody put in 5.8, they get something slightly different.
Yeah, 3820.
Okay. So what did you use?
2.575
Okay.
divided by 0.02 to the second power.
Yep. So you might get something slightly different. So in that case, you get you get 3819, which is 320.
Wait, did you have the 2.58? Is that when you changed the?
He did 5.6, so I'm not sure why.
Oh, I used the on my T table. It says, here, I'll show you now.
But that totally works. That also works as well, right? You could totally do that and you get 38. Right, so those are all fine. As long as you show me,
Right over here.
okay, as long as you show me what you did, you have to show me your work. If your work matches this and you round correctly, then you're good. If you use 2.58, then you'd get what?
3834.
3834?
Yeah.
And that's rounded correctly?
Yes.
If you use 2.58, then you get 3834.
There's multiple answers for this
Yeah.
one.
Yeah, but the key is you have to show me what you wrote down so I know that you rounded correctly. All right,
Interesting.
sounds great. I will see you folks. We will do problems 3, 4, 5, and 6 at the review session. This is actually 0.008. Thank you.
Have you ever driven through Nevada?
Which means that it would be 3835. Okay, good, thank you so much.
Thanks, Michelle.
Sure, thank you.